The IP addresses you have learned about so far are 32-bit addresses. Taking into account every possible IP address, there are just under 4.3 billion possible IP addresses. However, out of those 4.3 billion addresses, many are special addresses that cannot be used for host devices. With the growth of the Internet, more and more devices need an IP address to connect to the Internet. As more and more devices connect, we are quickly running out of available IP addresses. Recent estimates show that the last available IP address will be requested sometime in the year 2011. A year or two following that, all ISPs will have given out their last available IP addresses. It is likely that the situation is not as dire as predicted, and there are some other solutions that could possibly be implemented to extend the lifetime of the 32-bit IP addresses used on the Internet. Over 10 years ago, a group began work on the design of a new addressing standard, IP version 6, with the previous addressing being labeled IP version 4. The main goal of IPv6 was to overcome the depletion of the 32-bit addresses, so the biggest difference between IPv4 and IPv6 is the size of the IP address. IPv4 addresses are 32-bit addresses. IPv6 addresses are 128-bit addresses. Where there are slightly less than 4.3 billion IP version 4 addresses, even though the address is only 4 times longer, the IPv6 address provides for an exponentially larger address space. One way to write this is 3.4 times 10 to the 38th power. I'm not a mathematician, but that's a lot. IPv6 addresses use 8 divisions within the address. Each of these is called a quartet and consists of 4 hexadecimal numbers. Each quartet is separated by a colon. For example, here's a sample IPv6 address. Each number within the IP address can range from 0 to 9 or A to F. There are several ways to simplify the IP version 6 address. One way is by omitting any leading zeros within a quartet. So for instance, this quartet could be written as simply 8CA, and this one could be written as AB. Trailing zeros must be left as they are. So in this case, this must remain as 2300. Another way to shorten the IP version 6 address is to take blocks of quartets that are all zeros and to leave those out and replace the zeros with a double colon. So in this case, I could do FEC2. I would replace these quartets with a double colon and then follow that with the rest of the IP address. One rule when omitting quartets of zeros is that you can only omit one block within the address. For instance, I could not omit this block and this block at the same time. One reason for that is if you omitted more than one block, it would be difficult to know how many quartets of zeros you have within each omitted block. I could, however, do this. In this case, I have omitted this block of zeros and substituted it with a double colon. Obviously, the first example is more efficient in that I write fewer zeros when writing the address. But either way is a valid form of representing the address. An IP version 6 address is divided into 2 parts right down the middle. This part on the left is called the prefix, and the part on the right is called the interface ID. In terms of IP version 4 addresses, the prefix is similar to the subnet or the network address, and the interface is the host address. Notice that with IP version 6 addresses, all hosts have a fixed size address. The prefix can actually be divided into several other parts that have some significance. For example, the first 3 digits within the prefix vary based on what are called regional internet registries. In other words, different parts of the world are assigned different numbers within this first 3 in the IP version 6 address. When talking about the prefix, it's common to use a slash notation, similar to what we've done with the IPv4 address, to identify how much of the prefix we are talking about. The entire prefix is designated with a /64. When we talk about the regional internet registries, they use the first 12 bits of information within the address. The next portion is typically allocated to individual internet service providers. So numbers up to the second quartet are assigned to individual ISPs. And this portion of the prefix is designated using a /32. The ISP is then free to allocate addresses within the remaining portion of the prefix. A typical organization might be to take this portion and assign that to a specific site or an individual business. And then the business can use this information to use for subnetting. So within my business, I may be able to vary the numbers within this quartet to create my individual subnets. The interface ID can be dynamically generated by an individual host using an algorithm that virtually guarantees uniqueness throughout a site. The interface ID can also be derived from the MAC address. However, in this case, a MAC address is a 48-bit number, and the interface ID is a 64-bit number. The way the MAC address is modified is by taking the MAC address and inserting the values FFFE in the middle of the MAC address. So for instance, in examining the interface ID, if I were to see right in the middle the values FFFE, I could possibly assume that the MAC address was used to generate this interface ID. There's one other transformation that is used to take the MAC address and convert it to an interface ID, and it involves setting a value in this quartet, but we'll not discuss how that works. The main thing to be aware of is that the interface ID can be based off of the MAC address or dynamically generated. In addition to providing more addresses, designers took the opportunity to add improvements to IPv6 that did not exist in IPv4. These include built-in security and quality of service and auto-configuration features. Even though IPv4 addresses might soon be depleted, there has been very little push to adopt IPv6 on a large scale. Current estimates indicate that less than 0.5% of hosts use IPv6 addresses. It is estimated that the move to IP6 will not occur until the situation becomes mandatory through the use of all IPv4 addresses. Although you might not use IPv6 addresses now, you need to start learning about IPv6 so you are ready when the transition becomes necessary.